In this learning session, we will be learning about integers. Now, what are integers? A number system consisting of natural numbers, the number 0, and negatives of natural numbers is called a set of integers. And a set of integers can be represented by using the symbol z and enclosing the numbers belonging to z in the within the braces. As I have shown here, z is equal to inside the braces 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5 is a set of integers, endless on at both the ends. Now z also can be represented as z plus minus 1, plus minus 2, plus minus 3, and so on. It is a set of integers. A set of whole numbers and negative natural numbers is known as integers. Now, when I talk about negative natural numbers, it means that if 1 is a natural number, then minus 1 is the negative natural number. Now, the symbol of a set of integers is z. The least integer is infinite because it is endless on the left side, and the greatest integer is also again infinite. Every integer has a successor. Every integer, for example, 0 has a successor 1, 1 has a successor 2, 3 is a successor of 2, 4 is a successor of 3, and so on. So also 0 has a predecessor minus 1, and minus 2 is the predecessor of minus 2 is the predecessor of minus 1, minus 3 is the predecessor of minus 2, and so on. So that means every integer has a successor as well as a predecessor. Every integer has a consecutive integer. For example, 1 is a consecutive integer of 0. 0 and 1 are consecutive integers. 2 and 1, so all these are consecutive integers. Okay, we already know what are consecutive integers. And also you have to remember that the symbol of integer z, which represents here as 0 plus minus 1 plus minus 2, is a set of integers. And so also we have z plus, it is a set of positive integers, and z minus is a set of negative integers. So please remember that 0 has no sign. Integers number line is the next thing what we have to learn. Integers number line is a horizontal line which represents integers. It means we have a horizontal line on which we have marked the integers. On the line we have 0, which is represented by a point, and towards the right of 0 we have the positive integers which are placed at equal distances, and to the left of 0 we have negative integers which are again placed at equal distances. So we have positive integers on the right of 0 and negative integers on the left of 0. Remember that. Now 0 is neither negative or positive. 0 is having no sign. The values of the numbers increase when we move from left to right of the number line. So if you see here, 0 is greater than minus 1, minus 1 is greater than minus 2, and plus 5 is greater than plus 4. Therefore the values increase as we move from left to the right of the number line. Now to understand ordering of integers, integers on the left of an integer is smaller. 1 is smaller than 2, minus 1 is smaller than 0 to the left. Whereas on the right, the integers are greater. 2 is greater than 1, 0 is greater than minus 1. So always remember, to the left they are smaller and to the right they are greater. So 0 is greater and it is greater than every negative integer, and 0 is smaller and smaller than every positive integer, which is for us to remember. Next point of our discussion is negative of a negative integer is a positive integer. What does this mean? If we have 5, the negative of integer 5 is minus 5, but if you find the negative of negative 5 is again plus 5. So negative of a negative integer is always a positive integer. That means minus of minus a is also always equal to a. Now let us understand with an example. If you take the number line plus 1, if I take the negative of plus 1, that means I have to go to minus 1. If I take negative of minus 1, again it becomes plus 1. So minus of minus 1 is what is called as 1. So minus 1 is the image of plus 1 and plus 1 is the image of minus 1. So therefore remember, the negative of a negative integer is always a positive integer. The next point of our discussion is absolute value of an integer. Now what is this absolute value? Now if I move from 0 towards the right 5 steps, then I get plus 5. If I move from 0 to the left 5 steps, I get minus 5. But I have moved 5 units to the left, 5 units to the right. That means this 5, which is the magnitude of the number, is what is called as the absolute value of integer 5. Therefore, absolute value of an integer is always positive. It is never negative. It can be 0 but never negative. And the absolute value is represented by putting two parallel lines across on either side of the number. So absolute value of 5 is 5. Absolute of minus 5 is also 5. It is always a positive integer. So remember that. Okay, absolute value of 0 is 0. So absolute value can be 0. Absolute value can be positive but never negative. So please remember that. Operations on integers. Now when I say about operations on integers, that means we have to discuss about addition, subtraction, multiplication and division. So let us begin with the addition. Already we know what is addition. Addition is repeated. Please remember what is addition. So now for example, two integers if I take plus 5 and plus 3, when I add plus 5 and plus 3, okay, we get plus 8. That means sum of two integers, positive integers, is always a positive integer. Now let us understand with the number line. So plus 5 means I have to move 5 steps to the right, so plus 5. Again plus 3 means I have to add plus 3 steps to the right, we get plus 8. Remember that. Now if I take minus 5, that means minus 5 is 5 steps to the left, that is minus 5. Again 3 steps to the left, that is minus 8. So minus 5 plus minus 3 is minus 8. So addition of two positive integers is again a positive integer. Addition of two negative integers is a number with is a negative integer. That means if the integers are both positive or negative, if both the integers are positive or both are negative, then add the numbers, put the same sign. This is the rule. The rule of addition is if the integers are positive, add the numbers, put the same sign. If the integers are negative, add the numbers, put the same sign. So the rule is if the integers are both positive or negative, that means they have like sign, then add the numbers and put the same sign. Now this is again, if you look at this, there are two integers here. One is plus 4, the other one is minus 2. So plus 4 adding plus minus, that is adding minus 2 to plus 4 is plus 2. Adding minus 6 to plus 4 is minus 2. So let us understand this using a number line. So now plus 4 is 4 steps to the right. Minus 2 means 2 steps to the left. Plus 4 minus 2 becomes plus 2. And also plus 4 means 4 steps to the right, and minus 6 is 6 steps to the left, we get minus 2. The rule is if the integers are of unlike signs, see the signs are unlike here, one is plus 4, the other one is minus 2. So if the integers are of unlike sign, then subtract the smaller from the bigger and put the sign of the bigger. If the integers are of unlike signs, subtract the smaller from the bigger, so that is 6 minus 4 is 2, put the sign of the bigger, and that is the rule. So if the integers are of unlike sign, then subtract the smaller number from the bigger number and put the sign of the bigger. Now subtraction of integers. Subtraction, 6 is an integer, 5 is also an integer, I have to subtract it. Please remember, the subtraction is nothing but addition by changing the sign of the subtrahend. So this, therefore, that means the additive inverse of minus 5 is plus 5. So we can change it. So 6 minus 5 becomes 6 plus that is minus 5. Additive inverse of plus 5 is minus 5. And when we add, you know that 6 plus of minus 5 is plus 1, because the signs are unlike. So please understand, the signs are unlike. We have to subtract 5 from 6. So, and subtracting, putting the sign of the bigger number. Now let us understand with the help of a number line. 6 means 6 steps to the right. Minus 5 means 5 steps to the left. We get plus 1. So therefore remember that every subtraction is an addition by changing the sign of the subtrahend, by taking the additive inverse of the subtrahend. So if you have plus a an integer, plus b is an integer, if you want to subtract it, it is nothing but addition of a to additive inverse of plus b, which is minus b. It means that minus 8 minus of plus 7 is minus 8 plus additiveness of plus 7, which is minus 7. So minus 8 plus of minus 7 becomes minus 15, and it's very easy to understand it. We can go 8 steps to the left of the number line and 7 steps to the left of the number line. So minus 8 minus 7 becomes minus 15. The signs are like, so we have to add and put the same sign. Remember that. Multiplication of integers. When we multiply 3 with minus 5, a multiplication is nothing but repeated addition. That means I have to add minus 5 3 times. So from 0, minus 5, jump to minus 5. From minus 5, again minus 5, jump, minus 10, again minus 5, jump minus 5, it is minus 15. So 3 into minus 5 is minus 15. So let us understand this by the procedure what we have to understand here. That is minus 3 into 5 is minus 15, because when we multiply 2 and 5 we get 10. When we multiply 1 and 5 we get 5, that is 5 less. When we multiply 0 and 5 we get 0, again 5 less. When we multiply minus 1 into 5, it is again what, 5 less, that is minus 5. Minus 2 into 5 is minus 10, again 5 less. Minus 3 into 5 is minus 15, and therefore multiplication of minus 3 with plus 5 is minus 15. The rule is multiplying integers with unlike signs. See, please understand, the signs are unlike here. One is plus, the other one is minus. Then multiply the numbers and put a minus sign. So this is the rule of multiplication of two numbers with unlike sign. Now multiplication of two integers with the same sign, that is negative sign. Now let us take, for example, minus 3 into 2 is minus 6. Minus 3 into 1 is minus 3, 3 more. Minus 3 into 0 is 0, again 3 more. Minus 3 into minus 1 is 3, again 3 more. Minus 3 into minus 2 is again 3 more, that is 6. That means if we have two integers with minus sign, minus a into minus b, the product is with a plus sign a into b. That means the product of two negative integers is a positive integer. It's a very important rule which you have to again remember. So minus 4 into minus 2 is multiply the two numbers and with a plus sign. That means two negative integers when multiplied we get a positive integer. Now, what is the sign convention of multiplication of integers then? Multiplication of two unlike signs, minus and plus, is always minus. Plus and minus is minus. So, product of unlike signs is always negative. Whereas the product of two like signs, plus into plus is plus, minus into minus is plus, that is product of like signs is always positive. I have taken an example here. Plus 2 into plus 3 is multiply the numbers. 3 into 2 6, plus into plus is plus, minus into minus is plus, 3 into 2 is 6, plus into minus is minus, 3 into 2 is 6, minus into plus is minus, 3 into 2 is 6. So remember, whenever we take the product, first multiply the sign as per the sign convention. Plus into plus is plus, 3 into 2 is 6, minus into minus is plus, 3 into 2 is 6, plus into minus is minus, 3 into 2 is 6, minus into plus is minus, 3 into 2 is 6. Again, a very important procedure which you have to remember. Now let us consider the division of integers now. When we multiply an integer a with b, we get c, or c is also an integer. That means this is the very important closure property of multiplication, which is closed for a set of integers. Now for a multiplication statement, we have two division statements, that is c divided by b is equal to a, or c divided by a is equal to b. Now we can use this what we call the operations to understand the division of integers with different signs. If 3 into 5 is 15, then 15 by 5 is 3, 15 by 3 is equal to 5. Minus 3 into 5, the product is unlike signs, so minus 15. So when I divide minus 15 by 5, I get minus 3. So division of minus with plus is always minus. Division of minus with minus is always plus. So this rule we have to remember. So therefore, minus divided by plus is always minus, unlike signs minus, unlike signs minus, like signs plus, and like signs plus. Division of unlike signs is negative, and division of like signs is always positive, which we have to remember. Now properties of integers. Now we know the properties of natural numbers and the properties of whole numbers. So if we are clear about properties of natural numbers and whole numbers, then properties of integers is much easier, because we know that natural numbers is a subset of whole numbers and whole numbers is a subset of integers. That means all the properties of whole numbers are all closed for a set of integers. So even then, to understand, let us discuss. So closure property of addition. Closure property of addition. What is this closure property of addition? If we have two numbers a and b, a is an integer, b is an integer, when we add, c is again an integer, c belongs to z, means if the sum of two integers is again an integer, then closure property of addition is closed for a set of integers. Let us take an example. 7 plus of minus 2 is plus 5. 7 is an integer, minus 2 is an integer, and plus 5 is also an integer, and therefore the closure property of addition is closed for a set of integers. So the sum of integers, if it is an integer again, then closure property of addition is closed for a set of integers. Let us talk about closure property of subtraction. Closure property of subtraction was not closed for natural numbers, also was not closed for whole numbers, and for the reasons are very clear. But here, if you take two integers a and b, which belong to, that means z is a set of integers, then a minus b is equal to c, c is also an integer, then the difference of integers is again an integer, therefore closure property of subtraction is closed for a set of integers. Let us take an example. 7 minus of plus 10 is 7 plus of minus 10, that is minus 3. I have taken the additive inverse here, therefore subtraction becomes addition. When I take addition, I have to take the additive inverse of plus 10, that is minus 10, and the sum is minus 3, that is addition becomes minus 3, which again belongs to z. Minus 3 is 100% a member of integers, and therefore closure property of subtraction is closed for a set of integers. Now closure property of multiplication. If two integers a and b are multiplied, we get again an integer c, therefore closure property of multiplication is also closed for a set of integers. Minus 5 into minus 3, minus 5 is an integer, minus 3 is an integer, product is 15, which is again an integer. If I take minus 5 into plus 3, both are integers, the product is minus 15 is again an integer, therefore closure property of multiplication is closed for a set of integers. Now let us talk about the commutative property of addition. Now already we know what is commutative property of addition. If you have two numbers a and b, we can add b to a or a to b. The order of addition will not change the value remains the same, and it is true for a set of integers, and therefore commutative property of addition is closed for a set of integers. For example, 5 plus of minus 6 is minus 6 plus 5, minus 1 is equal to minus 1, LHS is equal to RHS, and therefore the commutative property of addition is closed for a set of integers. So also the commutative property of multiplication, what it states that if I take a product of two integers a and b, or if I multiply b to a or a to b, the product remains the same, and therefore the commutative property of addition multiplication is closed for a set of integers. A very simple example here. 5 into minus 6 is minus 30, minus 6 into 5 is minus 30, that means LHS is equal to RHS, and therefore the commutative property of multiplication is closed for z, because the integers multiplied in any order has the same product, again which is an integer. Now associative property of addition, which is, we already know that we can add the numbers grouping them in any order, whether I add a and b first and then add to c, or add b and c first and then add to a, the answer remains the same, and it is applicable, it is true for a set of integers, it is closed for a set of integers, and therefore we say associative property of addition is also closed for a set of integers. Similarly, associative property of multiplication is closed for a set of integers, and we already know what is associative property of multiplication. Multiplying a to b and then to c, or multiplying b and c and then to a, the answer remains the same, the value remains the same, and therefore integers can be grouped and multiplied in any order. And therefore remember that associative property of addition and associative property of multiplication both are closed for a set of integers. Now already we know what is additive identity. Additive identity, you know that it existed for whole numbers, where 0 is an additive identity, and so also it is true for integers. When we add an integer to 0, we get back the same integer, and therefore addition of 0 is the integer itself. Additive identity is closed for a set of integers. Now additive inverse, this is a very important property which is applicable for integers, not applicable for both natural numbers and whole numbers, very much applicable for integers, because when I take an integer a and add minus a to it, then I get 0. That means sum of two integers, if it is 0, then one is the additive inverse of the other. Minus a is the additive inverse of a and a is the additive inverse of minus a. Therefore remember, if sum of two integers is 0, the one integer is the additive inverse of the other. So here plus 3 is the additive inverse of minus 3, minus 3 is the additive inverse of plus 3, which are very much there present in a set of integers, and therefore additive inverse is closed for a set of integers. And multiplicative identity, already we know that it is closed for a set of natural numbers also, whole numbers also, and 1 is the multiplicative identity, and here it is also closed for a set of integers, whereas 5 is an integer. When multiplied by 1, we get minus 5, which again is an integer, and therefore multiplicative identity is closed for a set of integers. Now distributive property of multiplication over addition. And what is this? When I multiply a with b plus c, I can multiply a with b and a into c and a by c, and I get the same answer, and it is true and it is closed for a set of integers. The distributive property of multiplication over addition is closed for a set of integers. So also distributive property of multiplication or subtraction is also closed for a set of integers. If I multiply a with b minus c, I can also multiply a with b and a with c with a subtraction sign in between. We get LHS is equal to RHS, which is very much closed for a set of integers, and therefore distributive property of multiplication over subtraction is also closed for a set of integers. Now operations of 0. Operations of 0, we have already discussed this in the learning lesson on whole numbers. Here again let us understand the operations of 0 on integers. If a is an integer, and when you multiply an integer a by 0, we get 0. 0 is an integer, therefore product of an integer with 0 is always 0. So product of an integer with 0 is always 0. And so also when I divide 0 by a, we get 0. That is applicable. We can follow this. 0 by a is 0. That means 0 when divided by an integer is always 0, and the reason is the 0 into a is 0. Division of 0 by an integer is 0. Division of 0 by an integer is always 0, and it is very much defined. Please remember that. But when I divide an integer by 0, it is not defined, but because we get the value which is totally not defined, is very clear to us. Therefore 0 divided by a is 0 is defined, a divided by 0 is not defined. Please remember that. Operations by 1. You know that a into 1 is equal to 1 into a is equal to a. A is an integer. When multiplied, we get back the integer. The product of an integer with 1 is the integer itself. A by 1 is a, but 1 by a is not closed for z, because 1 by a, it does not exist in a set of integers, and therefore a by 1 is equal to a exists for a set of integers, whereas 1 by a, it does not exist for a set of integers, because division, closure property of division is not closed for a set of integers, which is very, very clear. So please remember this much, and as I have already told you earlier in my previous learning sessions, listen to what I have spoken, read every word of what I have given as a lesson here for reading, and then repeat the reading and listening, and then ultimately at the end you scribble everything on in a book, so that you can have them as a reference for your future use. Thank you.